Hi, welcome back to the Trusted Data Architect channel. I am Anil Sripada. In episode 4 of Project SourceTRU, we look at one of the most important platform questions. How do events become a trusted current state? In the last episode, we followed a raw event through the platform. In this episode, we go one step deeper. We ask what happens after events arrive. How does the platform decide what is true now? If this series is useful, please subscribe to the channel. It helps me keep creating practical enterprise architecture content. An event is a record of something that happened. A current state is the platform answer about what is true now. These are related, but they are not the same thing. A baggage system may send an event saying loading is complete. A gate system may say the gate is ready. A movement system may say the aircraft has arrived. Each event gives us evidence, but the platform still has to decide what those events mean together. It has to decide what changed, what was confirmed, and what should not be overwritten. That is why current state must be built. It is not simply copied from one event. In real operations, messages do not always arrive in the right order. A system may send an event late. A network issue may delay a message. A batch file may arrive after a real-time feed. If the platform simply processes messages in the order they arrive, it can produce the wrong answer. A late event may describe something that happened earlier. It may confirm a state we already suspected, or it may contradict the current answer. A trusted platform cannot assume arrival order equals business truth. It must understand the difference between when the event happened and when the platform saw it. Event time and processing time answer different questions. Event time tells us when the business event actually happened. Processing time tells us when the platform received it and processed it. Both matter. Event time supports business truth. Processing time supports platform observability. When the two times are close, the state decision may be simple. When they are far apart, the platform needs to be careful. The event may be late, it may be stale, it may be a duplicate, or it may be a correction. Without both timestamps, the platform has less evidence to explain its decision. Not every event should change the current state. Some events are valid and should be accepted. Some events are incomplete and should be quarantined. Some are duplicates and can be ignored. Some correct a previous message. Some supersede older evidence. These choices should not be hidden inside code. They should be part of the architecture. The event log keeps the evidence. The state layer records the platform decision. This gives the organization consistency. It also gives consumers confidence that the answer was produced through rules, not through accidental overrides. A common implementation shortcut is last write wins. The latest arriving message overrides the current value. This is simple, but it is not always correct. The latest message may come from a weaker source. It may describe an older business event. It may be a duplicate. It may even be wrong. A trusted platform needs precedence rules. These rules combine source authority, event time, sequence, correction flags, and freshness. Overwrite logic is not a coding detail. It is an architecture decision because it controls what the business believes. Corrections happen in real operations. Boarding can start, then pause, then resume. A gate can be assigned, then changed. A baggage status can be marked complete, then corrected. If the platform treats corrections as rare exceptions, it will be fragile. A trusted platform expects corrections. It preserves the original event, it records the correction, it updates the current state, and it can explain why the answer changed. The consumer may only need the latest answer, but the platform must keep the path that led to it. State without history is hard to trust and hard to repair. This is why the event log is important. It is not only a technical store, it is the evidence record. If a rule changes, the platform can replay the events and rebuild the current state. If a consumer questions an answer, the platform can show how the answer was produced. If a defect is found, the team can fix the rule and rebuild state from the original evidence. This is much stronger than trying to repair a final table after the evidence has been lost. A current state can also carry confidence. Early in the journey, confidence may be low because key evidence is missing. When the aircraft arrives, confidence may improve. When the gate becomes ready, it may improve again. If a source becomes stale, confidence may fall. If two authoritative sources conflict, confidence may become lower until the conflict is resolved. This is important because a trusted platform should not only provide a value, it should also communicate how much trust it has in that value. The current state model should be designed. It should define allowed states and allowed transitions. For example, a flight may move from scheduled to aircraft arrived, then gate ready, then boarding, then ready, then departed. Some transitions are normal, some are suspicious, some require a correction event, some require manual review. When these rules are explicit, the platform behaves consistently. This is how architecture turns operational events into reliable enterprise state. Once the platform builds a trusted current state, it should not expose it as a private internal table. It should publish it as a governed data product. A data product has a contract. It defines fields, meaning, ownership, freshness, and access rules. Different consumers can then use the same trusted state in different ways. A passenger view may show a simple answer. An operations view may show evidence, confidence, and exceptions. An executive view may show trends and risks. The underlying state is shared, but the access and detail are controlled. A trusted answer should be usable and explainable. The consumer may see an expected departure time. They may see confidence. They may see the current flight state. But the platform should also preserve the evidence passport behind the answer. That passport includes source, event time, processing time, validation result, lineage, and freshness. This is the difference between a dashboard value and a trusted intelligence output. A dashboard may show a number. A trusted platform can explain why that number should be believed. The airport example makes the pattern concrete, but the architecture problem is common. Banks build account state from transactions. Healthcare platforms build patient state from clinical events. Logistics platforms build shipment state from scans and exceptions. Utilities build service state from meters, outages, and field events. In each case, events arrive from many systems. Some are late, some are corrected, some are incomplete. The reusable architecture question is the same. Which event should change the state, and how can the platform explain the answer? The main takeaway is simple. Trusted state is built, not simply stored. It is built from events, evidence, timestamps, rules, corrections, history, and governed access. If this episode helped you, please like the video, share it with someone working on data platforms, and subscribe to the Trusted Data Architect channel. Please also leave a comment. What is harder in your environment? Late events, corrections, duplicates, or explaining the current state? In the next episode, we will look at data quality as an operational capability. Thank you.